Bismillahirrahmanirrahim. Assalamu alaikum dear students. Welcome back in DAM analysis and design forces to be considered. I already did this topic in part 1. Now we have to proceed to a problem. Please watch part 1. Because if you don't watch that part 1, you don't understand this part 2. Because here we are solving a problem. So here we have a problem. The problem is that we have to find out basically what earthquake, earthquake forces and movements. The dam height is given, that is 100 meter. The freeboard is given, that is 1 meter. The batter which is provided to upstream side is given, clear? And taking alpha, that is earthquake pressure coefficient, that is given. Hydrodynamic earthquake pressure and its movement. At a joint situated at a 50 meter below maximum water level. So I draw the figure here. I have a height that is around about 100 meter which is given. Now what thing we have, remember the water level is from the top, which is called a freeboard, is a distance of 1 meter. Remember, this is water, this is 1 meter. Clear? This is freeboard, remember. And a batter, remember this is upstream side. I already explained this, what is upstream side and what is downstream side. Clear? This is downstream. Now water is basically falling, so that's why, and they are flowing in this direction, so that what is downstream and this is upstream. Water is basically damming at that side, so that's why this is upstream. Now what we have, basically we have to determine hydrodynamic forces, and the pressure distribution of hydrodynamic forces is already explained in part 1. This is in parabolic shape. We have to find out what PEY. What is PEY? I explained this in part 1. At a distance of how much? At a distance of y equals to 50 meters. That is given. And we have to find out PEY as well as we have to find out MEY, movement of this. Now the batter or the slope which is provided to the upstream side is given 0.15/1. Remember. Clear? Now what we have to do, remember, let me show you that how we can do. This is hydrodynamic pressure. Clear? Here you see PEY, CY, we need CY. If you need CY, then you need CM. So what is CM? CM is theta divided by 90. So we need theta. So theta is what? Theta is this one, angle with the base. This is theta. Now how we can determine it? Remember, this line is inclined with this vertical line. So this angle, let's say I assume this is pi angle. Clear? So I can determine this pi angle from this slope. Remember, this is tangent pi equals to what? Slope is given. This slope means that 0.15 times in 1. This is perpendicular and base. Means that 0.15 you have to rise 1 meter. For a 0.15 meter horizontal distance, then you have to rise for a distance of 1 meter. This is 0.15. Clear? So this will make your tangent. So this angle is nothing, 0.15 divided by 1. If you need pi, you just need to tangent inverse of that term. 0.15 divided by 1. Clear? You got your phi value. But as pi, remember, this is a perpendicular line. If I draw a perpendicular line right here, so this angle will also be pi, and you know this theorem. Clear? Now if I got this phi, I can determine this theta. How? This angle is 90 degrees because this line is perpendicular and this is also perpendicular. So this total angle is 90. So if I subtract this phi from 90, I got this theta. So theta is what? 90 minus pi angle. Clear? It will give you theta. Then you determine CM. CM is what? 0.73, I think so. 0.735 theta divided by 90. Okay, 0.73 what? 0.735, sorry, 35, and you got theta divided by 90. Yeah. So this is how we can determine Cm. Once you determine your Cm, then you need to find out your Cy. Cm value, y is 50, h is 10 meter, 100 meters, sorry. You do the calculation, you got your Cy. Okay. And then you need to determine what? Then you need to determine PEY, that is the total pressure at depth this much. Okay. That is pressure intensity, total pressure. This is pressure, okay. This is total pressure, not that one. This is pressure intensity. So this small PEY you write, see here, this one and this one. There is two. This is this value. Cy, you got your Cy, just put here. Density, that is density of water 1000 and H is 100. You got this one, okay. Then plug that value here. Plug the value of Y, that is 50. You got your PEY, that is total pressure at the depth Y, and your movement, that is 0.299 PEY dot Y square. Okay, you got your that value. Let me show you the rest of the calculation. Okay, that did. They calculate pi value. You see here that is at 0.5 degree. They determine theta, clear. They determine Cm, that is 0.66, clear. The Hy is given, okay. And then they determine Cy. Cy is 0.538. Then find out Pey. Pey is this one. And you see 1000, that is the density of water, that is height of dam, and 0.1 is the alpha earthquake coefficient, okay. And Cy is this one, clear. So this one, this is not centimeter square, this is square meter, clear. And Pey is what? That is this one. You need to just plug this value here. Y is 50. You got your total earth pressure and the movement of the earth pressure, that is due to hydrodynamic force. This one value you have to just, Pey is this one, Y is 50. You just plug the value. You got your hydrodynamic pressure movement. Okay. So this ends up that problem. Let's see the next problem. We do, okay, a little part of this example 8.3 and the rest will be inshallah in part 3. Okay. A masonry dam 10 meter high is trapezoidal in section. Remember trapezoidal in section. Trapezoidal in section means, okay, this like this shape. Yeah. This may be vertical or it may be inclined. Okay. Trapezoidal shape. 1 meter its top width and bottom is 8.25. Clear? The space exposed to water. Let's say we assume this space is exposed to water and it says that a better, so this line is not perpendicular, line is inclined. And a better means slope which is provided to that side 110. In example 1 you see 0.15:1, but here is 110. This is the stability of the dam. Okay, you need to find out sliding factor and you need to turning. Okay, you have just to check those things. Please watch part 1. Find out the principal stresses. Okay, sigma 1, tha, at the toe and heel. This is 2, this is 2, and this is heel. Remember, this is heel and this is 2. Yeah? So you must know what is heel and what is 2. Assume unit weight of masonry dam is 2240 kg per cubic meter. Weight of water, that is the density of water, 1000. And permissible shear stress, that is Q. Remember, this is Q. That is 14 kg per square centimeter. So you need to convert this into meter square. For that purpose, you have to just 10 to the power 4. That is kg per square meter. Okay. Assuming no free vote, and you just do the calculation for 1 meter length. And I already mentioned this, that you have the length of the dam in this side. So we just consider 1 meter strip of the dam. Remember, just one. Be ignoring the rest of part. Clear? So we design for 1 meter. Now we find out the self-weight of the dam. How we can determine the self-weight of the dam? Remember, let me show here that let's say this is top width, this is a dam, okay. Here this line is 1 meter and this total is how much? 8.25 meter. Remember the other dimensions are not given. This is 8.25. Clear? Now you draw a one line perpendicular right here. You need to draw one perpendicular right here. Clear? So the better is 110, which is provided to this face. Now how much this distance will be? From the slope you can determine this one. Okay. The total height of the dam is 10 meters. 10 meters. So from the slope it is clear that 110 slope means if you going down 10 meter, okay, then your horizontal distance will be 1 meter. So that's why as the height is 10 meter, so this distance will be 1 meter. Okay. And here we have this one is 1 meter, so that's why we say that this one will also be 1 meter because both lines are parallel. So this distance will be how much? Now this is easy. Subtract this 2 from 8.25, you got 6.25. Okay. So this is the way that how we can determine the dimension, the missing dimension. Clear? Now we need to find out basically what we need to find out this weight of this body. So as you see, this is a trapezoid, okay. This is a trapezoid. So we need to find out its area. Now the area of a trapezoid is how much? You all know. Top width, that is 1, plus bottom width, that is 8.25, divided by 2. We need to average it and we need to multiply with height. Okay. So this formula will give you the area of trapezoid. Now you need the weight of this body. Okay, weight of this body. So weight will be nothing. This is just only area times density. Density of this body. Okay, it will give you the weight. So once you got your area, you need to use the density of this dam, and that is 2240 kg per cubic meter. Remember, masonry. Okay. So this will give you the total weight, or you can say total V, or total weight of this dam body. Clear? So here I did the same calculation. Okay, you see here 8.25 and 1 divided by 2, 10. Okay. So I think this is clear right now. Okay. I determine all. One thing is very important. They basically determine the vertical forces. So once you determine this weight, so this one is 1, okay, 1 weight. The other vertical force is, let me complete it, okay. Remember this side is 1 meter and 10 meters. So there and another triangle, and I already explained this in part 1, that here we have basically water. Okay, here we have water. Now this water body basically provide extra support to this dam, and they are causing balancing of this dam. Clear? So that's why it is very important that we need to determine also this force, and it also exerts a force, okay, a vertical force. This is also exert a vertical force. Okay. Here we have one vertical force, here we have other vertical force. Now the value, remember, this distance will be how much from, remember this is vertical line, so this is 1 meter, this is also 1 meter. So we need to find out the area of this figure. The area of this figure will be how much? Look, half, this is triangle, half times this base 1 times height, that is 10. Okay, this will be the area. Now the vertical force or the weight of this water body will be area you got here times density, and density of water, because this is water, so that's why you multiply A with 1000. And let me show you, here you see 1 divided by 2000. Okay, this will give you that amount. Now the next is uplift force. Remember, as uplift force, I already discussed it in part number 1 of this. Okay. So what we have to do basically, remember that here we have water which is dam on that on this upstream side, remember, on this upstream side. So the water basically trying to escape just below the bottom. Okay. So that's why when they are moving, this movement of the water is basically known as seepage. And once the water moving in the form of seepage, they basically exert pressures on the base of the body and causing imbalancing of the dam. Okay. So the distribution of the pressures of the uplift pressure will be in this triangular shape, and I already explained this in part 1. Okay. So here we have the resultant of that uplift force, and that uplift force is denoted by U, remember. And this force will be, if I show you, let me show you this one. You see U, 1 over 2, C, B, H, density. C is 1 and B is 8.25, H is 10 and density is 1000. So that's why this density, this U value will be determined. Okay. And its lever arm will 2 by 3rd, remember, of 8.25. It will work later. Okay. I will show you. So this is very important. Okay. This is very, very important. Okay. Here you see the uplift force 10,000 2 times B. Okay, the same formula which I show you here, this one. Clear? So you calculate your uplift force now. Remember, here you see this force, this V. This is in positive direction. This is in downward direction. This force is also in positive direction. Therefore, it is positive. But this force is in upward direction, so U will be negative. So therefore, whenever you are calculating summation of V, you just need to consider this is positive. You just need to consider this one is also positive, but that U will be with negative sign, remember. And here you see the first one is positive, the second one is positive, and the third one is negative. Clear? That one. The uplift one, that. Okay. Now, horizontal water force. Remember, as the water is basically dammed at the back, okay, or upstream side. So as in lecture number part 1, sorry, I already explained that water is basically exerting pressure. Okay, as water here. Okay, and you all know that hydrostatic pressure, it exerts an hydrostatic pressure, and that hydrostatic pressure will be in triangular shape, and it acts at a distance of h by 3, that is its movement arm or lever arm, and its amount will be P, and this will be 1, 2 times h square times density of water. Clear? So that did the same calculation here, you see here. Okay, 1000, that is density h 10 square divided by 2, so 5000. So these are total vertical horizontal forces. Okay, and the rest calculation is for movements. So let's finish the movement and then we stop this video. Okay, so how we can determine right now the movements? Clear? This is a very important step. Okay, how we can determine these movements. Okay, so let me show you. Okay, here we have to, what we have to do, here we have to do, let me bring a new page here. Okay, let me, a new page here. Okay, so let me draw the figure again. Okay, let's see how we can write. Clear? This is the downstream side. Okay, this is the total figure. Okay, this one. Now this side is also inclined. Clear? Here we have to distribute the whole body into parts. This is A3, this is A2, and this is A1. Clear? And the water body which is right here, okay, we have also to be determined. Now, this is 2 point, okay, and we need to calculate the area of this triangle, the area of this rectangle, the area of this triangle, the area of this triangle. And then we need to find out their movement arm from this 2 point. Clear? Now, first they determine the area of this figure. So the area of this figure is what? A1. Okay. I already did this calculation. Look, this is 10 meter height. Clear? This is 10 meter. So the area of this triangle A1 is half times 10 times 1, because this distance is 1. This distance is 1, this is distance is 1. Okay, this is 1 and this is 6.25. Clear? Now, 1/2 times 10 times 1 times, this is area, sorry, this is area. This is just area. Clear? This is just area. Now, what will be its movement arm? That is x1. Okay, so its movement arm will be 6.25 plus 1, that is 7.25. Clear? And plus, we need to add up, remember, this resultant force of A1 acting as this is perpendicular. Okay, so that's why from this side it will be 1/3. From that side it will be 2/3. So that's why I use 1/3. So 1/3 of that base, and base is 1 meter. Okay, base is 1 meter. So the moment M1 will be F1 times x1. Okay, so the total calculation will be 1 to 10 times 1 times, now you need to find out its weight. So that's why you have to multiply this area with density. So that's why density 1000, because this is weight, this is load, and you have to multiply it with this one. So 7.25 plus 1/3 of 1. Clear? You need to separate it. Okay, you just do this one and then multiply. Okay, this is separate. Okay, so let's see. Here you see A1, 1 to 1, 10, 2, sorry, I really sorry, this is not 1000 because this is dam material, so that's why 2240. Clear? Yes, and the rest of calculation you see. Similarly, you need to do the calculation for A2, A3. A2 will be same, 1 times height times density 2240, and then you need to find out its moment arm. That moment arm is how much? 6.25 plus this 1 divided by 2. So x3 in this case basically 6.25 plus 1 divided by 2. Okay, and then for A3 is how much? 1/2 times 6.25 times 10 times density, that is 2240, times x3. Now in this case x3 will be this one, and that is 2/3 of 6.25. Clear? You must remember. Let me show you the calculation. Here you see for A2 110 22 and that one. Clear? And for A3 you see the same calculation which I did. Okay, so these are the movements due to self-weight of the body, of the dam body. Now the next movement is that you have to find out the movement of this water body. Remember, this will be at a distance of this much. Clear? Now this is total weight, then you need to find out its moment arm. Okay, this will be its moment arm. So the weight of this movement body already we determined, okay, in step 1. Now we need to find out this x. So you know the whole distance is 8.25. Clear? So from 8.25 you need to subtract this distance, and this distance will be how much? This is a triangle. This is a triangle. Clear? This is a triangle. So here we have. Okay. So from this side this is 1/3, and from this side this is 2/3. So you just need to subtract 8.25 minus 1/3 of 1. This will give you that x. Or you can other approach is that as the distance from this to this point is 7.25. Okay, so 7.25 plus you need to add up this distance, and that distance is now 2/3, because that is from that side is 2/3, and from this side is 1/3. So 7.25 plus 2/3 of 1, or either you can use this one or you can use that approach. So let me show you the same approach, that is minus 1/3. Okay, so minus 1/3. Clear? Here you see. And for uplift force, as I already did this in that first step, basically the uplift force, you all know better that is also a triangular distribution. Clear? Sorry. That is also a triangular distribution. So in this shape, and there is a resultant, and that resultant acts at a distance of 2/3. So you determine the uplift force, which is right here. You just need to multiply this one with this 2/3 of 8.25. Clear? This will give you the moment of uplift force right here. 2/3 of 8.25. Then you need to find out your water pressure. So you determine your water pressure, just multiply it with 10/3, because all you know that the water pressure acting at a distance of how much? h/3. So that is the lever arm. Okay, and this makes a movement in this direction. One thing is very important, which I finally discuss with you. Remember, there are some restoring movements and some overturning movements. Okay, the body of the dam, which I got M1, which I got this one and this one, M3, M2, M1, these are restoring movement. They are causing the balancing, so they will be in positive sign. Similarly, the water body, which is right here, is also acting in this direction, and they are also causing this type movement. That is also a restoring movement about this point, this 2 point. But the water pressure, basically, the water pressure is the red one. Remember, that causing overturning movement about this 2 point. So that is with negative sign. And similarly, the uplift pressure, which is from the bottom, is also causing a clockwise, or you can say imbalance movement. So that will also be considered as negative. Okay. So let me show you. Remember, summation of movement. When they are summing the movements, you see the first two will be your restoring movement. Remember, these are your restoring movement. Sum of MR. And these two are your overturning moment. Remember, M0. Okay. And the total movement will be this one. Sum of movements, M. So that's why if you do your stability analysis, inshallah I will do in next lecture, okay? So you must remember these points. Summation of MR and summation of MR. So if you have any question, any suggestion regarding this lecture, you can share. Okay, thank you for watching.